Hello everyone, I hope you guys are doing good. So today we'll be discussing another problem of our Blind 75 series, and the problem of the day is decode ways. So here we have a message containing letters from A to Z that can be encoded into numbers using the following mapping. A gives 1, B 2, similarly Z for 26. So to decode an encoded message, all the digits must be grouped when mapped back into letters using the reverse of mapping above. There may be multiple ways. For examples, 11106 can be mapped into 1 1 10 6. It can also be mapped into 11 10 6. Note that grouping 1 1106 is invalid because 06 cannot be mapped into F, since 6 is different from 06. So given a string S containing only digits, we have to return the number of ways to decode it. So this is a classic dynamic programming problem, which would be first discussing using a recursive approach. So let's say, for example, we have 2 to 6 as the given number. So for this, we know that either we can start with 2 or we can start with 22, as 22 is less than 26 and it is also a valid start. So if we start from 2, we can either select 2 after it to go 2, 2, or we can select straight away 26 as it is also valid. For 22, we can only select 6. For 2 and 2, we can also go forward and select 6. So now we have 3 ways to approach 2 to 6. One's this is the second way, and this is the third way. So the best way to approach this problem is to start reversing our given string in the reverse order. And what we'll do is we'll maintain our DP and just put the length of S as a value of 1. This means that we are saying there's one way to reach the end. So now what we can easily see is there are few base cases that we need to look into. So while traversing from the end, if we ever encounter a 0, that means for that given element I for which we encounter 0, we do not have any way. Or I can say that dpi equals to 0, because 0 is not a valid code for any of the given letters. So either we'll have 1 in front of it to make 10, or 2 in front of it to make 20, so that it could be a valid code. So when we encounter 0, we'll just put dp of I equals to 0, as you can see over here. Else, what we'll do is, if it's a general letter from 1 to 9, we'll just say that dp of I equals to dp of I plus 1. I'll also show a dry run for the given example, which would help you understand better. So let's say here's 1, and this is our dp. And now you can easily see that at position s minus, length of s minus 1, or here at 6, let me just write our input. So yeah, so at position 6, we know that this is n not a 0. So we'll just put dp of I is equal to dp of I plus 1. That there's one way to reach the end from 6. And that's totally true. Then we'll move on to 2. And first what we'll do is we'll just put 1. But then we'll go into a check. And what we have to check is we have to check for the 2-digit valid codes for 10 to 19 and 20 to 26. So we'll just check first that we are at a position that is not the last position. This helps us in checking that I is less than len of s minus 1, or we are not at the last position, or we are not at 6. So if we are at 6, we cannot check for a 2-digit number as this is the last number. So we'll just move on after checking this and check if s of I, the current element right now is 2, is 1, or s of I is equal to 2, and s of I plus 1 in 0, 1, 2, 3, 4, 5, 6. So here we are checking s of I is equal to 1. This will include every condition of 10 to 19, and the condition after or will include every code from 20 to 26. So if this is the case, what we say is, we say that dp of I equals to dp of I plus 2. It simply says that either going from one position, either going and jumping from one position from here to here, as we did in our last index, what we can do is directly go from here till the end, or till the next 2 position. So what we do is simply add dp of I plus 2. I plus 2 is 1, so it becomes 1 plus 1, and it would be 2. Now we'll go to the first position. It's a 2. So similarly, there are 2 ways, either to take a 2 and start with it, or take a 22. So similarly, we'll add dp of I plus 2. So we'll add 2 plus 1. It would be 3, and simply return 3. So in this problem, as you can see, we are only using a single dp array. So the space complexity would be big O of n, and the time complexity would be big O of n as well.